Hello, I'm Robert. Welcome to my channel where I fact check the stories that scare you. And this is about the people who are still getting scared about Apophis. And we are no risk at all from Apophis. It's not going to hit us in 2029 or 2036, and it's very easy to deflect if it turned out that we need to do anything about it in the 2060s. So Apophis, if I go look at that, if I make this image a little bit smaller, a second. So just so you can see that red bit. So this is just the distance. It's not the actual direction it'll fly past. So that's the distance of geostationary orbit, where this is where you can orbit the Earth once every 24 hours, and that means that a satellite stays always above the same point on Earth, geostationary Earth orbit. And this is where Apophis passes by, which is closer than geostationary Earth orbit, but this is how accurate they have it. And remember, I explained in the previous video that we can calculate orbits of asteroids very exactly, and it's basically the same mass that we use to send spacecraft to other planets, like the reason that we can send Perseverance to Mars, and we know whether it's going to arrive in the right place, go into orbit around Mars, and go into orbit, and then it can land the point at which it's going to land, even just landing without orbiting first with Perseverance. And in the same way, we just although the way you measure it is differently, we don't have Apophis taking photographs of the stars and sending them back to us. We take photographs of Apophis, which we can't do with Perseverance, and then we see where it is against the distant stars. And by taking lots of photographs, then we can see which way it's going. But it's the same idea as when we get a spacecraft to take photographs of the stars and then send that back to us, and then we use that to work out where it is. And then we also use the speed of the travel back and forth, and his photographs of Mars and so on. So that's how we do it with the spacecraft, and with the asteroid, then we take photographs of the asteroid whenever it's close enough to Earth to be seen. Asteroid's much bigger than the spacecraft, and so that's how we know exactly where Apophis is, by all these photographs we've taken over the years, as just a dot against the stars. And if you've got, I think it's three photographs, then you could already work out what it's. Let me just stop and check that one. Yes, that's it. It's Gauss's method, and it's if you take 3 observations, then you can get a preliminary orbit from what you're looking at, and then more than 3 increases the accuracy of the orbit. So we know they have lots and lots of observations of Apophis. There are many astronomers observing it all the time. Every day you'll find they've been observing it again, and so we know its orbit very accurately, and that's where the distance it will pass by in 2029. And then this is a much better. This gives you where it is that it passes by. So it actually passes on the outside of the geostationary orbit satellites, but it gets closer to Earth than them. So it doesn't come near any of our satellites, but it just skims past them. So that's what it's going to do, and we know that very exactly in 2029. Now, so the thing to notice here, notice how there's an actual change. It's not a straight line. So if it was far away from Earth, it would just be going pretty much a straight line, because compared with the distance to the Sun, it's actually orbiting the Sun, but it's orbiting the Sun in such a huge orbit that it would just look at a straight line at this time, on this distance, on this scale. And so that curve is entirely because of the gravity of Earth. So every time an asteroid flies past a planet, then it changes its orbit like that. And so that means it's in a different orbit around the Sun after than it was before. Now, this is very, very sensitive. So that's why at one point they thought it was going to, at first they thought it could hit in 2029, when they only had a few observations. As they got it more accurately, and it was always in this orbit, it was never in a different orbit. But they, as they calculated the orbit more exactly, they then found out where it was going to pass more exactly, and they realized it was going to miss in 2029. But then it's very sensitive, and this is what they mean when they talk about it flying through a keyhole. So this means that there was a certain point it could fly through, which is a tiny little region in space here, which if it flew through it, then its orbit would be bent by just the right amount to hit Earth in 2036. So that was much harder to deal with, because it's very, very sensitive to how far away it passes by Earth. Because it depends much, if it passed here, it would depend much more. If it passed by there, it depends much less. And then for another 7 years after that, that very slight change is enough to change significantly where it is in 2036. So that's what the gravitational keyhole is. It's not something that pops up in the middle of space suddenly from nowhere. It's always to do with flying very close to a planet. And so they eventually found, they eventually got more and more accurate. They got this accurately enough so they knew exactly which way it's travelling after it passes by Earth. So they now know it's going to miss in 2036. But still, as it flies past in 2039, as it flies past in 2026, they will be observing it very carefully, and they will be observing it with radar. And I know the Arecibo radar station has closed down, but there's another one that is operating, and that's the deep space one that receives radio signals from our very distant spacecraft. And that one can actually broadcast out to them. It has to, in order to communicate with them, and so that means it can do radar. And so the Goldstone Observatory but it doesn't want to do too much radar, because it won't be able to get the next image down from Perseverance, say, if it is doing a radar imaging of an asteroid. But it is there, and if necessary, it can take a break from communicating with our distant spacecraft to do radar imaging of a nearby asteroid. So that's always there. And then the new capabilities are bound to be built, and hopefully by the 2029 it's far enough in the future that we could have the ability to send out, because radio telescopes generally, they receive radio signals and they don't have the instruments attached to them to send signals out again. And so it's a case of whether someone has added that capability to a telescope, and that depends on that could be quite a heavy instrument. And it's a question, for instance, China building a very, very sensitive radio telescope, but the detector that is got to be suspended above it, it just can't carry the mass for a transmitter to transmit out again, so it won't be able to do radar. So you have various things you have to look at here. So anyway, but they're bound to add radar capability again to take the place of the Arecibo telescope. So anyway, we will have lots of observations, visual observations and radar observations when the Apophis flies past in 2029, and that will be much more precise orbit by then, and then that probably will rule out the collisions in 2060, because it's just like in 2029 it never was going to hit, but they just couldn't calculate this orbit well enough. Well, actually, if we could calculate its orbit very, very well, then we would know already about the 2060s. I'm pretty certain. And you get people talking about there's an effect that the heat, the sunlight from the sun, and it's a very, very minute effect that can cause it to change its orbit very, very slightly. And that's really only significant for these flybys, setting it up for the next flyby and for decades and so on. Even then it's not a big effect. And they can measure the amount of it. They measure how Apophis deviates from the perfect orbit without this effect, and then they build that into the calculations. So that is taken account of as well. and so so the sensationalist press make it out there's all these uncertainties and these asteroids can swerve around and do all sorts of stuff. And just totally false. They can't do that. So when it does fly past, then it'll be like if you've seen the Seven Sisters, this will be actually visible to naked eye, but only from a good dark night. If you've got any cloud at all, you won't see it. And if like a flimsy cloud would easily obscure it. And then it would be quite difficult to see from a city because of the city lights. You need to be able to see these Seven Sisters and see some of the very rather fainter ones. And if your eyes aren't very good, then again you're not going to see it except with a telescope. So or binoculars. You'll be able to see it with binoculars pretty easily. You'll be able to see it with binoculars easily. And you should actually see it with binoculars. It'll take 9 minutes to cross the field of view, and at 10 times 50 binoculars, I think you would notice it as a faint star is very, very slowly moving. Just look at the star field for a while, and you'll see that this faint star is moving. This is about what it could do to Earth. So Apophis, this is a wave height of 1 meter. So Apophis, I talked about in my previous video. I'll put a link to this video. It's about 2001 FO32, because I talk about some of these things there. But I'll just mention it briefly, that an asteroid like this, even Apophis, is not big enough to do a really big tsunami. And it's got a big splash of 100 meters, and then tsunami wave height would go down to 10 meters very quickly, and then it's 1 meter at this distance. So if it landed in the middle of the Atlantic Ocean, then you wouldn't even get 1 meter get to the shores. But if something like this was to land very close to the shore, just a few kilometers offshore, then it would cause quite a big tsunami. So an asteroid of this size, it can cause, it can't do anything to the Earth as a whole. It can't even create a tsunami that would affect very large areas of Earth in a significant way. But it could if it fell near to a city. But remember, we are following it very, very closely. We're going to deflect it, and by then, even more so, we'd have radar imaging of it as it came close to Earth. Even if we decide, you can imagine someone maybe deciding our astronomy is so good, we know it's going to land in the middle of the Pacific, and we just want to watch this thing and just let it land. If it landed in the middle of the Pacific, I mean, tsunami would be so very minute. You would even imagine astronomers kind of lobbying to let it land if it was on a collision course, just to watch what happens. But because it would cause so little harm. But that's what Apophis is like. If it lands in the sea, and if it landed on the land, it would create a small crater if it landed on the land. And to have an image of that, yes. So if it landed in New York City, then that's how far away from New York City the glass windows would shatter. And so if you were in the Great Lakes, you wouldn't notice, you wouldn't get anything if it landed in New York City. Now, the chance, only 1% of Earth's surface is city anyway, or urban areas, and very minute chance of any asteroid is going to hit actually hit a city. Even for thousands of years, it's very unlikely. So, but just supposing it was going to hit, and there was a risk, then you can deflect it very, very easily. And so suppose we discovered in 2029 or in 2036 that it is going to hit Earth sometime in the 2060s. We don't expect that. We expect to discover it's going to miss. That's the most likely thing by far. But suppose we discover it's going to hit. Remote possibility, very unlikely. And these only are every 100,000 years or so that something like this will hit Earth. Then what we can do is send a spacecraft and land a little bit of solar sail material and spread it out over the surface. And they worked out that a 40 meter by 40 meter patch, so that's 130 feet by 130 feet. If think in terms of feet, then that would be enough. That would have been enough in whenever this was. When did they do this? 2018 mission. So missions could have, if they had seen it was going to hit in 2036, they could have sent a mission in 2018 to add 130 foot by 130 foot patch of lightweight solar sail material, and then that would have been enough to, by that effect which I just mentioned before, and it's called the Yarkovsky effect. And by the Yarkovsky effect, then this just a small amount of solar sail material would have been able to shift its position so that it would miss. So the way this works is that sunlight hits Apophis, and then as Apophis spins, then it radiates away the heat from the sun in a slightly different direction from where it came from. Now, even if it wasn't rotating, sunlight would be doing something to it. The sunlight hits the Apophis, the heat reflects back again, that would constantly be pushing it outwards. But because it's spinning, then it's the actual direction in which it's shifted by Yarkovsky effect depends also on the spin. So if it spun forwards, then it would shift it backwards in orbit. If it spun backwards, it would shift it forwards in its orbit. And so that's the Yarkovsky effect. And so then if you add a mirror material on the surface, then that will completely reflect all the sunlight. It doesn't heat up. You get a slightly different Yarkovsky effect, and that is enough to, and it does it instantly instead of heating it up, and then at night it radiates away when it gets cool. And so if you do that, then that can change its orbit just by adding some reflective material to the asteroid. And Apophis, we see that Apophis is one of the easiest asteroids we have to deflect. So if it was flying past in 2039, we could just add some solar sail material to it to deflect it in 2036, in the 2060s. Indeed, if we knew in 2029 that there was going to be a risk sometime in 2060s, it can't hit between 2039 and 2060. We know that from its orbit. So we've got at least 21 years to deflect it if we find it's going to hit, which is we don't expect to. So that and then if the astronomy lobby succeeded and they said no, we suppose it was going to hit the Pacific, and some astronomers lobbied to let it hit in order to find out more about the effects of asteroid impacts, then actual practical study of what happens if an asteroid hits Earth, then if that lobby was to succeed, I'm just making up an imaginary lobby, no astronomers are actually saying we should do this, but you could imagine the future with a lot of confidence in people actually lobbying for this. You just could imagine it. Just imagine it succeeded, then it would just be a case of warning people, keep out of the way. If you're a sailor, keep out of the way where it's going to hit in the ocean, and it would just be warning all shipping around that area to keep well out of the way, because we want to let it hit as an experiment. So, and if an asteroid was ever headed for a city, and we discovered it even just a week in advance, that is plenty of time. You get people saying, oh, we can't evacuate cities. That's not true. We've got better and better at this with hurricanes, and the key is to contraflow. What you have to do is to turn all your roads so that you can only drive out of the city and you can't drive in. You might keep some roads somewhere, small roads for people who absolutely have to get in, but the bulk of the traffic is heading outwards and you can't go backwards. You can all one way outwards. If you do that, then you can evacuate a city very quickly, and then you have to set up lots of buses for the people who can't, who haven't got cars, and you've got to make sure that all those buses, of course, can get into the city, and they're sitting there waiting, and then they just go off in a great big fleet, and with everyone else who can't go on the cars, and then some of them will come back and get more necessary if necessary. So using those methods, which has actually been done in practice, then you can evacuate a city in a couple of days. You can evacuate a city even less than that. So with a week of warning, then we have these emergency plans already. People know how to do it. So they would just go out and they just change the signs. So the sort of the roads going out in contraflow, tell everyone what they're doing on television and radio, organise this fleet of buses and make sure that all the buses are in place, and then they can evacuate the city in a couple of days. If necessary, they can even evacuate faster than that and get nearly everyone out. And then the only problem then would be stubborn people who don't believe that an asteroid is going to hit Earth, or who think they can survive it somehow, which you get sometimes with hurricanes. So as long as we've got a warning, and then even for a big asteroid, but we know all the very big ones above 10 kilometers, I've explained before. We know nearly all the ones above 1 kilometer, the none above 10 kilometers can hit us for thousands of years. There's one at 1 kilometer that can hit us in 4 centuries, but is expected to miss, just like with Apophis. We expect it to miss, we expect to prove that it's going to miss as we study it better, 1950 TA. And then below that, there's no possibility. That's the smallest asteroid that could throw up enough dust to make the atmosphere cloudy enough for a few weeks to impact on the harvest of, if it's the growing season, on the other side of the Earth. So a global effect on the harvest for 1 year, of reducing the harvest by some percentage for a year. So that's a global effect. So that's below 1 kilometers, you can't do that. So you can't have any global effect. That's a very rough estimate, it's around about 1 kilometers. So anyway, so that's my Apophis debunk, a nice short Apophis debunk, and I'll put the link in the video description. And yeah, I've managed to get it down to 22 minutes, and just shout out to our group, Facebook group Doomsday Debunked, and my channel to like and subscribe to the channel. And then if you do join our group, we very welcome people who have expertise in astronomy of any sort, including of course amateur astronomers. We have amateur astronomers, we have people with good knowledge of astronomy in the group already, but the more the better, because you still get people who ask a question about astronomy and maybe they'll get an answer for an hour or a few hours, and someone is panicking there, and the more people we have that can respond quickly, the better. And about asteroids, or about sometimes things like galaxies, if you don't know much about asteroids, but you have a basic understanding of stars and how fast stars move, which is very slowly, and things like that. And you know what a planet is, and things like that. Then this basic astronomical knowledge can be very useful for members of the group who have as little understanding of that as I do of my Russian that I studied at O-level. When I was at O-level, I did O-level Russian because I was interested in it, but I've forgotten just about every word. I know placebos, stuff like that, that's about it. I'm useless at languages. So other people are similar with science and maths and astronomy, and so they come and they're just terrified by these totally fake asteroid warnings that you get in the sensationalist press, and other things like claiming that the star is going to harm our solar system, or some ridiculous ideas like that. So we very much welcome astronomers if they want to come and help in the group, and also people who are scared of astronomical things.